All right, let's jump right into this explainer, and honestly, let's just shift our entire mindset right from the start. We really need to stop seeing AI as this unpredictable black box magic. If you've ever felt like getting a good result was just, well, luck, this is for you. We're going to treat prompt engineering exactly as what it is, an empirical science. Welcome to a masterclass where we're breaking down the latest research from the absolute pioneers of large language models. By the end of this, you'll have the actual tools to control AI outputs, moving from just guessing to guaranteed consistency.
So how do we actually tame the black box to consistently get reliable results? I mean, you've probably been there, right? You give an AI a prompt one day, get a brilliant answer, and then try something almost identical the next day and get complete nonsense. We are going to fix that inconsistency today. We're transforming your whole approach from hopeful typing to deliberate, structured engineering. We've got a clear roadmap today to level up your skills. We're covering the science of prompting, zero-shot versus few-shot learning, formatting and context, chain of thought reasoning, and finally, success criteria and evaluation. From basic interactions all the way up to pro-grade evaluation frameworks. Let's get into it.
First up, Section 1, the science of prompting. We need to understand alignment and steerability and establish what's actually happening under the hood.
Let's get one thing straight. Prompt engineering is a science that requires heavy, structured experimentation. At its core, it's really all about alignment and model steerability. We aren't retraining the AI, right? We aren't changing its internal memory weights. We're simply finding the precise communication methods to steer its existing knowledge toward exactly what we want. Think of it kind of like tuning a radio dial to catch the exact frequency of the answer you need.
And model selection matters before you even type your first word. You absolutely have to tailor your approach. Standard GPT models, they act a lot like a junior coworker. Incredibly fast, but they need explicit, precise instructions so they don't wander off track. You tell them, extract exactly 3 names and format them as a bulleted list. But reasoning models act much more like a senior coworker. You give them a high-level goal, like analyze this Q3 report and summarize the strategic risks. And you actually need to step back. You have to give them the space to work out the fine details themselves.
Moving on to Section 2, zero-shot versus few-shot learning. Let's focus in on the core differences between these two massive, foundational techniques. The contrast here is actually pretty stark. Zero-shot learning is exactly what it sounds like. You just feed the task text directly to the model and ask for a result. Like, is this review positive or negative? Bam! It's incredibly quick and uses way fewer tokens. But few-shot learning, that is where things get genuinely powerful. By presenting high-quality demonstrations, like say feeding it 3 specific examples of positive and negative reviews first, you clearly show the AI your exact human intentions. Yes, the trade-off is that it costs more tokens and eats up your context window, but the performance boost you get is usually massive.
Now, a quick heads up. You can't just pick random examples when you're doing few-shot learning. The specific choice and order of your examples can literally swing performance from a totally random guess to near state-of-the-art. Research shows we should be using techniques like KNN clustering. That's just a fancy way of saying we find examples that are mathematically and semantically similar to your current test case. Also, you have to randomize the order. Large language models suffer heavily from recency bias. They tend to just lazily repeat the label of the very last example they saw. So keep those labels balanced so the model doesn't just guess whatever output you showed it the most.
All right, Section 3, formatting and context. Let's look at how giving our instructions a rigid framework builds a rock-solid foundation.
Think of this as your blueprint for the perfect developer message. You really want to help the model understand logical boundaries. So you start with identity, who the AI is, then instructions, what it should and definitely shouldn't do, then your few-shot examples, and finally, the context, the raw data it actually needs to analyze. To make this foolproof, use markdown headers to cleanly separate these sections. And here's a pro tip. Wrap your raw context data inside XML tags. It creates this clear, virtual fence that stops the AI from confusing your permanent rules with the temporary data it's just processing.
But hey, optimization doesn't stop at formatting. Technical best practices are what keep your outputs consistent day in and day out. If you've ever had a prompt randomly break on a Tuesday, this is why. Pinning your production apps to specific model snapshots, like say version 4.1 for a specific date, is absolutely crucial. AI is naturally non-deterministic, right? Also, put your repeated context instructions at the very beginning of your prompt. This lets you utilize prompt caching, which helps the model remember the rules without reading them every single time. Honestly, it leads to massive cost and latency savings.
Let's level up to Section 4, chain of thought reasoning. This is where we unlock complex problem solving, especially for math and logic.
It's wild, but this simple, incredibly famous phrase triggers what we call zero-shot chain of thought. Just by adding "let's think step by step" to your prompt, you explicitly force the model to generate a reasoning chain before it spits out an answer. Instead of just asking, "what's 15% of 82?" and letting it instantly guess, you force it to write out its internal scratchpad logic first. It stops, breaks the problem down into short sentences describing the math, and only then provides the final answer.
So when do you actually use this? Well, chain of thought is your absolute go-to strategy specifically for complex reasoning. If you use it on simple, everyday tasks, you're honestly just getting slight processing overhead for very little gain. But for complex math or logic puzzles, where standard prompting often fails completely or confidently hallucinates the totally wrong answer, chain of thought generates rationales that make the output highly accurate. Researchers note this is especially powerful when you're using massive models with over 50 billion parameters.
And we can push this even further with advanced extensions. Take self-consistency sampling. Instead of generating one single answer, you generate multiple diverse answers at a higher temperature, meaning you turn up the AI's creativity setting a bit, and you simply take the majority vote across those answers. It's brilliant for ensuring accuracy. There's also this technique called self-ask. You prompt the model to repeatedly ask follow-up questions to construct its thought process iteratively. You can even pair those internal questions with a live search engine to pull in real-time facts.
Finally, Section 5, Success Criteria and Evaluation. This is it. This is the absolute professional edge that separates the novices from the masters.
According to the leading API documentation, before you even think about tweaking a prompt, you have to follow this workflow. You define what success looks like, and you build empirical evaluations to test it. That means creating a strict baseline, like a spreadsheet of 100 diverse test cases with known, correct answers. Only then do you draft your prompt and start iterating. Listen, if you don't have a system to empirically test your changes against a baseline, you are essentially flying blind, just crossing your fingers and guessing if your new prompt is actually better than the old one.
And here's a quick reality check. Prompt engineering is not literal magic. If your evaluation is failing because the response is taking 10 seconds too long, or it's costing your business way too much money per call, endlessly tweaking the words in your prompt won't save you. In those cases, the data is screaming at you that you probably just need to select a faster, smaller, or cheaper model entirely to meet your success criteria.
Let me leave you with this to chew on. Researchers are already building augmented language models like Toolformer that use these exact structured prompts we've been discussing to teach themselves how to use calculators, browse the web, and manage calendars autonomously. Mastering these precise prompts today, it's not just about getting slightly better text generation. It is the fundamental key to controlling and communicating with the autonomous AI systems of tomorrow. Thanks for hanging out with me on this explainer, and definitely take these techniques and start experimenting with them right away.